Hello everyone. Today I am going to tell about fundamental theorem of arithmetic. Before going to discuss about this, I am going to tell about what are prime numbers and what are composite numbers. See this number line here 2, 3, 5, 7, 11, 13, etc. These type of numbers are called prime numbers because if you take factors for each prime number, for example 2, the factors are 1 and 2 and 3, 1, 3 and 5, 1, 5 and 7, 1, 7 like this. So the prime numbers have only the number itself and one or the factors. So these type of numbers are called prime numbers and the remaining numbers are called composite numbers. So here composite numbers are 4, 6, 8, 9, 10, 12, etc. If you observe the factors for each composite number, there are many factors. For example 4, the factors are 1, 2, 4. 1 and 4 are the number itself and 1 and the remaining factor is 2. And for here 6, the factors are 1, 2, 3, 6 and for 8, 1, 2, 4, 8 like this. So for composite numbers there are many factors. One is neither prime nor composite number and the smallest prime number is 2 and the smallest composite number is 4. Now, the numbers which have only two factors, 1 and the number itself are called prime numbers. For example, 5, 11, 13, 29, etc. These type of numbers are called prime numbers. And the numbers which have more than two factors except 1 and the number itself are called composite numbers. Example, 4, 22, 25, 100, etc. And 1 is neither prime nor composite and 2 is the smallest prime number and 4 is the smallest composite number. Now we know that a composite number has many factors. So now I am going to tell how to write a composite number as product of prime factors. For example, if you take 6, 6 is a composite number and we can express 6 as 2 into 3. These two are prime numbers. So we can express a composite number as product of two prime factors here. And 35 is also a composite number and we can express 35 as 5 into 7. These two numbers are prime numbers. And 462 you can express as 2 into 3 into 7 into 11. You can do like this. So these are the prime factors. So we can express 462 as the product of prime factors. So the process of writing a composite number as the product of prime factors is called the prime factorization of the given number. Now I am going to tell about prime factorization by using factor tree. For example, if you take a composite number 330 you can write as 2 into 165 first. Again 165 you can write as 3 into 55. And again 55 you can write as 5 into 11. So 5 into 11. So here these numbers are prime numbers. 2, 3, 5, 11 are prime numbers. So 330 you can write as product of these prime numbers. 2 into 3 into 5 into 11. That is 330. If you see here 330 you can also write as 3 into 110. And 110 again you can write as 11 into 10 and 10 you can write as 5 into 2. So 330 is equal to, you can write these prime factors, product of these prime factors. So 3 into 11 into 5 into 2 here. Again if you can express 330 like this, 11 into 5 into 2 into 3. Here see here the prime factors are in this order, 11 into 5 into 2 into 3. So if you observe all these prime factors, here all the prime factors are same. So here also 2, 3, 5, 11 and here also 2, 3, 5, 11 and here also 2, 3, 5, 11. So here prime factors are same but the order of writing the prime factors is different. So prime factorization is unique, that means same factors except the order of its factors. Now I am going to tell about fundamental theorem of arithmetic or prime factorization property. Every composite number can be expressed or factorized as a product of primes and this factorization is unique apart from the order in which the prime factors occur. Just now I told that every composite number, for example if you take 66, this is a composite number and can be expressed or factorized. So this you can express or factorized as product of primes, that means 2 into 3 into 11. These three numbers are prime numbers. So product of primes, and this factorization is unique, that means you can write the same factors in any order like 2 into 3 into 11, 3 into 2 into 11, 11 into 3 into 2. So here the prime factors are same but factorization is unique apart from the order in which the prime factors occur. So the factorization is unique, but the order of writing the prime factors is different. This is called fundamental theorem of arithmetic or prime factorization property. If you take x as a composite number, we can express this composite number x as product of prime numbers. So here p1 into p2 into p3 into etc. till pn. So p1 is less than or equal to p2 is less than or equal to p3 etc. till pn, because here this is in the order of ascending order. We are writing the prime numbers as in the order of ascending order. For example, see here 66 we can express as 2 into 3 into 11. So here 2 is less than, 3 is less than 11. Now I am going to tell how to find HCF and LCM of two positive integers by using fundamental theorem or prime factorization method. Before going to discuss about this, I am going to tell what are HCF and LCM. So we know that HCF is the highest common factor. For example, if you want to find HCF of two numbers 12 and 30, first write the factors of 12. We know that factors of 12 are 1, 2, 3, 4, 6 and 12, and factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. So here if you observe these two factors, here 2 is common, 3 is common, 6 is also common. But we have to find highest common factor of these two numbers. So here highest common factor is 6. So HCF of 12 and 30 is 6. And LCM is the lowest common multiple. So we have to find multiples of 12. That is equal to 12, 24, 36, 48, 60, 72, etc. So multiples are infinite numbers and factors are finite numbers. So multiples of 30 is equal to 30, 60, 90, etc. So lowest common multiple here is 60. See here, this is the common multiple. So this is the lowest common multiple. So lowest common multiple, that is LCM of 12 and 30 is equal to 60. Now I am going to tell how to find HCF and LCM by using prime factorization method or fundamental theorem. So first write the prime factors for product, express the composite numbers as product of prime factors. So 12 you can express as 2 square into 3, and 30 you can express as 2 into 3 into 5. So you can do like this. 12 you can factorize like this, and 30 you can factorize like this, and write the prime factors here. And HCF of 12 and 30 is equal to, first see the common factors here. Here 2 is common from both factors, 2 is common and 3 is also common. So HCF is lowest power common and lowest power, that is 2 to the power of 1 is lowest power. So 2 into, here common number is 3, so 2 into 3, that is equal to 6. And LCM is equal to, here you have to take highest power common and highest power, that is 2 square. So 2 square into, here the again common number is 3, so into 3, and the remaining numbers you have to write the remaining numbers, that is only 5, so into 5. So 2 square into 3 into 5, these two are common and highest power here, and here lowest power and common. And into, in the LCM you have to write the remaining numbers also. Here 5 is the remaining number, into 5, that is 60. So HCF is 6 and LCM is equal to 60. Now I am going to tell some properties of HCF and LCM. The first one is the HCF of two given numbers is not greater than the given numbers. For example, if you take 3 and 6, the HCF of 3 and 6 is 3, because here the common factor is 3, so HCF is 3. So it is not greater than the given numbers, and LCM is not less than the given numbers. So here LCM is common is 3, 3 into the remaining number is 2, so 2 into 3, that is 6. So LCM is equal to 6, so it is not less than the given numbers. So HCF is always not greater than the given numbers, and LCM is not less than the given numbers. Next one is two co-prime numbers HCF is always 1. For example, we know that co-prime numbers means that the numbers which are not having a common factor, except 1. For example, if you take 3 and 10, here 3 we can write as 3 into 1, and 10 2 into 5 into 1. So here there is no common factor for these two numbers. So these two numbers are called co-prime numbers, and here the common factor is only 1. So for two co-prime numbers, the HCF is always 1. and the LCM is product of the given numbers. So for two co-prime numbers, the LCM is always product of the given numbers. You can check like this. So here LCM is 2 into 3 into 5, because here there is no common factor, so you can write all the numbers. 2 into 3 into 5, that is equal to 30. This is the LCM of these two numbers, and if you multiply these two numbers, 3 into 10 is equal to 30. So product of these numbers, 30 is the product of the numbers. So two co-prime numbers LCM is directly you can multiply those numbers and then you will get the LCM. Next one is, if x is a factor of y, then the HCF is x and LCM is y. You can see with an example. For example, if you take x is equal to 3 and y is equal to 6, you can write the factors of 3 or 3 into 1 or 3, and y is equal to 6, so you can write the factors, prime factors, those are 2 into 3. So here HCF is equal to 3 and LCM is equal to 6. So HCF is equal to 3, that is nothing but x. So if x is a factor of y, then the HCF is x. You can directly write the HCF is x, and you can directly write the LCM is y, that is 6. See here, this is y is equal to 6, so the LCM is y. Next one, HCF of given numbers is always a factor of their LCM. Please remember this point. For example, if you take two numbers 12 and 30, find out HCF of 12 and 30 is equal to 2 into 3, that is 6. These are the common factors of these two numbers. So here HCF is equal to 6 and LCM is equal to 60. So we know that 6 is a factor of 60. That means it is 60 is divisible by 6. 6 is a factor of 60, means it is this number LCM is always divisible by HCF. So HCF is equal to 6, that is a factor of LCM, that is equal to 60. Next one, product of HCF and LCM is equal to product of the given numbers. For example, if you take HCF of 12 and 30 into LCM of 12 and 30, just now we have calculated these values. So here HCF is 6 and LCM is equal to 60. So 6 into 60 is equal to 12. The numbers are 12 and 30. So 12 into 30, that is equal to 360. Here 6 into 60 is 360 and 12 into 30 is 360. So here these two values are equal. Therefore HCF of AB into LCM of AB, two given numbers, is equal to product of the given numbers, that is A into B. So please do this practice worksheet. And here are the answers.